Good afternoon, ladies and gentlemen. I hope you're doing well. We're having a fantastic day over here answering concrete questions, concrete concerns. And we've got an awesome one today from James. James, thank you for the information. I'm going to go ahead and get started with this and hopefully be done by dinner. Just kidding. Hello, Dr. John. I have a volumetric concrete truck. Go you, that's awesome. My aggregate sources are scarce since they've all been bought up by huge conglomerates like blank, and they won't sell their natural river sand. So I'm assuming from that James, you're getting some type of a manufactured sand with a lot of fines in it, a lot of what's the word I'm looking for? Crushed, larger aggregate in there. Getting back to this, we have quite a bit of limestone, so the natural sand sources have been depleted and replaced with manufactured sand. I guess I should just read. Sorry about that. Our concrete is far above the big boys in workability, but I'm going for perfection. Oof, I don't know if I like that sentence. I've been fighting a false set and some bleed water. Time out. False set, as defined by ACI Concrete Terminology 2018, is the rapid development of rigidity in a freshly mixed concrete, cement, or freshly mixed Portland cement paste, mortar, or concrete without the evolution of much heat, which rigidity can be dispelled and plasticity regained by further mixing without addition of water. And that can normally come from some of the chemicals that you're using in your concrete. Could be a rapid evaporation loss due to solar irradiation or just the wind blowing. And to some degree, it can even be caused by certain aggregates or even certain binder like cementitious and cement materials. Okay, so bleed, I love the definition for bleed. And bleed water or bleeding is the autogenous or from within the self flow of mixing water within or its emergence from a newly placed cementitious mixture caused by the settling of solid materials within the mass. So normally, when you have a high water cementitious and a mix that has a higher paste to aggregate ratio, or it has a high plasticizer content, any which of those combinations, if there's just a little bit too much water, we see that that settling of heavier materials down and that squeezing of water from within the concrete to the surface, and of course that causes problems, and oftentimes that's caused by excessive water. So when I see a sentence like our concrete is far above the big boys in workability, but I'm going for perfection, it sounds as if there might be a combination that might cause excessive bleeding. Anyway, I have switched from the Shillstone curve to using the tarantula curve. And getting some good results. So that's the different methods of optimizing the concrete, and the tarantula was developed by the folks who work for Professor Tyler Lay at Oklahoma State University, where that's Haley's alma mater. There was way too much math in that sentence. I apologize. I surmise mixing through a screw is causing the false set, and wow, I just can't talk today, can I? The baby was up most of the night, so I apologize profusely. Anyway, so I surmise mixing through a screw is causing the false set and bleed, but do not know of any products to fight this. I don't necessarily agree. I have mixed plenty or used plenty of mix that have come out of mini and auger that had a major bleeding problem, but after we went through the optimization process, we had no bleeding issues. And yes, there are bells and whistles that you can add, and Haley's going to be sending you a DM to send some of that information to you, but I wouldn't necessarily say it's because of your auger that's causing this false set or even the bleeding problem. I would definitely say that's more related to either ambient environment, but most definitely your mix design and the materials that you're using. We've tried auger aids, which I believe to mostly be surfactants for concrete with limited success. There's also viscosity modifying admixtures. You mentioned colloidal silica, I think later on. But before I would add anything, I would go through the optimization process. Again, if you're using the tarantula curve, it seems or sounds like you're already going through that process. It just sounds like you got to ratchet back on your water or play with your water super P combination. I've also used the blank, in almost every mix. Mazel tov. You mentioned liking some mid-range reducers that perform extra well, and of course colloidal silica, both of which I need to start testing. Do you know of a couple brands that you prefer that I start with? Thanks for your precious time, Jim. No problem. James. I like James better. It's a great name. You know, I thought we had something that we talked about earlier today about crucial aspects for batch plants consistency. And we actually have a couple clients that we've dealt with over time. I was actually looking at one of the quality management books. And you know, James, it just turns out that sometimes we can have a mix that looks really good on paper, even if we've optimized it. But then when we go from that, I mean, shoot, James, you could have even gone from the book creek to the lab creek. But when it gets to the real creek, when it gets to that volumetric truck, you might need to dial it in. There might be some change that you need to make with the paste or with the aggregate to paste ratio. So for instance, you know, you might have created one hell of an aggregate, like driven down or driven up your aggregate to paste ratio, so you're using the minimum amount of paste that you need to make your mix creamy and dreamy and easy to use. But then if your materials are changing, if you get, you know, some natural sand some days or some manufactured sand, or your coarse aggregate is changing in consistency, variability, or at least the fine content, we're not even talking the source, that same mix, that same optimized mix, you might need to start adding more water to deal with some of the unintended fines or surface area that might have been contributed by this change in coarse and fine aggregate. So it might be that you have one or a series of good mixes on paper, but just because they're a good mix on paper doesn't mean they're working well in the plant, or in your case, the volumetric mixer. So before I would start recommending, I would definitely say that start tailoring the optimization process. If you're working with the tarantula curve, play with that aggregate. It's been years. Maybe we can have a little bit of a interview and then do a review, because we're doing the PMXDB. We could do a PMXDB using the tarantula curve, and maybe you can interview Tyler on his tarantula. So look forward to that, James. Thanks for an awesome question, and keep them coming, man. Hope this helps. Go Concrete! Beautiful!